Okay, so we need to talk a little bit about ion size. What we have here is a sodium ion and a chlorine ion. Now, a sodium ion wants to get rid of one electron, and in doing so, all those leftover electrons are pulled in closer to the nucleus, okay? It's like if we said form a circle, and then one person left out of that circle, everybody would scooch in closer. In this one, we've got this chlorine ion, and they're in a circle, and one electron comes to join the group, and so everybody has to spread out, and so it gets bigger. So basically what we have happening is when a positive cation is formed, you get a smaller ion, okay? The negative anion is larger. And when I say smaller and larger, I mean smaller or larger than the actual uncharged atom, okay? So look at this group. Lithium, here's the atom, here's the cation. Sodium atom, sodium cation. Potassium atom, potassium cation, okay? Each one got smaller as an electron was lost, okay? And then we go over to group 7, and we look at fluorine. Here's the cute little fluorine atom. Here's the fluorine ion, okay? Chlorine atom gains an electron, and we get the chlorine ion. Bromine atom gains an electron, and we get the bromine ion, okay? So positives get smaller, and the negatives get larger, all right? Okay, trends in ionization energy. Ionization energy means the ability to lose electrons. The ability to lose electrons, all right? Notice that sodium's first ionization energy, so first ionization energy means your first electron. So first electron would be here. This is your second electron. This is your third, and my calibration is really off, third, and this is your fourth, and so on, okay? So the ability to lose an electron and the amount of energy that it takes. So sodium will lose one electron, and that takes 495 kilojoules per mole. Look what it does to pull off a second electron. It jumps way, way higher. That's because sodium doesn't want to lose that second electron. It's in the +1 column, okay? It only loses one electron. To pull off that second one, you got to input a lot of kilojoules. Magnesium is a +2, okay? So it'll get rid of 1. It takes 738 kilojoules. It'll get rid of 2 for about twice as much. Look what happens when you try and take a third one. Holy cow, that's a huge jump. And you're going to find that as you go all the way across. Now chlorine doesn't want to give up. It wants to receive. So immediately you've got a large number here because chlorine doesn't want to give up an ion. It wants somebody, or an electron. It wants somebody to give it an electron, okay? All right. So then we have a table showing us the trend in ionization energy and versus atomic number. And I want you to notice, like you did before, these right here: helium, neon, argon, krypton, xenon. This time, this is a period. Oh, I'm sorry. No, it's not. It's a family again. That's a family. It's the family all the way over on the right side of the periodic table. Hey, John. So what we find out is that as you go down